everyone, welcome to Pepcoding. The question that we are going to solve today is called quicksort. First, let us understand the question and then we will head over to the solution. So we have been given an array. Okay. Using this array, we have to use the quicksort algorithm, and through that we have to sort this entire array. Okay. So we have this array given to us. If you remember, we have discussed about partitioning an array in the previous videos. So let us recall what partitioning does. We are given a pivot index, and using that pivot index, we put all the elements smaller than the pivot index towards the left and all the elements which are greater than the pivot towards the right. Okay. So over here also we'll use the partitioning algorithm, and with that we'll use quicksort. So let us see how we'll do that. We are taking our pivot to be the last element of the array. So over here our pivot is 4. After partitioning, the array will look something like this. We have 4. Let's see. Is 8 less than 4? No. Is 5 less than 4? No. Is 1 less than 4? Yes. Is 2 less than 4? Yes. Is 3 less than 4? Yes. Is 6 less than 4? No. Is 7 less than 4? No. And 4, we'll place it over here. Now, we have 8. 8 is greater than 4. So we'll place it over here. 5 is also greater than 4. So we'll place it here. 6 is greater than 4 and 7 is also greater than 4. So we have done partitioning the array. Now, after partitioning the array, what we need to do is that all the elements towards the left and all the elements towards the right need to be sorted. The pivot element is already at the correct position because after partitioning, we put all the elements smaller than it towards the left and greater towards the right. So 4, that is our pivot, is lying at its correct position. We do not need to touch it. So we have to use the smaller elements and the larger elements, and we have to sort them now. So what we are going to do in this case is that we will pass the arrays separately. That is, we'll pass from low to pivot index -1 in one part and the element next to pivot, that is pivot index +1 and high to the second array, right? So we'll pass this as a separate array and this as a separate array, and 4, that is our pivot, will remain at its position. So this is how we'll do partitioning, and we'll do quicksort. If you have not seen the partitioning video, I'll suggest you to go and check it out first because that will make understanding this video much more easier. Okay, so now let's head over to the compiler. Over here, if you can see, we have been given the partition as well as the swap arrays by itself, right? So partitioning will be done for us if we pass. So we will take a pivot, and we decided that the pivot was going to be the element which is lying at the last position, that is at high. Okay. Now, we need to find out the partition index, right? Because using the partition index only, we will be able to do the sorting part. So we find out the partition index and we will pass it to the partition function. We'll pass the array, the pivot, low and high. Through this, we'll get a partition index, that is, in this case, we had after partitioning 1, 2, 3, 4, 8, 5, 6 and 7. So the index of 4, that is 0, 1, 2, 3, 4, 5, 6 and 7. So 3 will be given over here. Okay. Moving on. We are going to call the function of quicksort twice using two parts of the array. The first part of the array which we are using is from low to pivot index -1. That is from here to the element which is just before the pivot, that is over here. So we'll pass the first array from low to pivot index -1. Okay. Now, second part which we are going to pass to the function will be, now our low will change. So low will now be this point, right? The point which is just after the pivot. So this becomes pivot index +1. And we'll go till high. Okay. Now we have to go to the base case, but before that, first let us do a quick dry run of what we are doing so that you can understand better. So we'll go and do a quick dry run. Over here, we started with an array. Let's see, 8, 5, 1, 2, 3, 6, 7, and 4. Right? So we were working with this array. Now, we took a pivot element and we took the last element to be our pivot element. So after partitioning, as we recall, our array became 8, 5, 6, and 7. So now this will be our array and it will replace the original array. So we'll work with this one. Okay. We have this array over here. We have 4 as our pivot. So we'll partition it into 2 arrays. One is all the elements towards its left and then all the elements towards its right. So over here our pivot element becomes 3. For this condition, we will change the array by putting all the elements smaller to it towards its left and all the elements greater to it towards its right, which is nothing. So we are going to take this as it is. And now all the smaller elements are in one array. Greater elements will be in one array, but over here we do not have any element which is greater than it, so blank, and it will be returned as it is. Now, for 1 and 2, 2 will act as the pivot element and all the elements smaller than it will be to one side. That is, over here we'll have 1, 2 will come as it is and all the elements greater than it will be to the other side. Again, we'll have the same thing again, right? So we are going to take all the smaller elements to one side, greater elements to the other side. We got a blank element and we are going to return from here. For 1, if we check, we'll again have 2 cases, but now there's nothing greater than it, nothing smaller than it. So from here also we'll return. Okay. Now let's check over here. We have 7 as the pivot index. So if I check for 7, after doing the partitioning, I'll have 5, 6, 7, and 8. So now our array for this part has changed. So we are going to replace it. And this change will also be made over here. So here also we'll have 5, 6, 7, and 8. Okay. Now 5 and 6 will be on one side and 8 will be at the other side. 6 becomes the partition element or pivot. So we will put 5 over here and here I'll have blank and blank will act as the eliminating or the returning statement. For 5, I have nothing greater, nothing smaller, so these will also not give me any answer. For 8, I have nothing greater, nothing smaller, and this will terminate. Okay, and now we have traversed the entire array and we get our sorted array. So now we are going to take our base case. Okay. I'm sorry, I ran it by mistake. Now we are going to ignore this. Over here, I'm going to take my base case. So what exactly will we write in the base case? Whenever we are working with the array, we are taking a low and a high, right? So low keeps on increasing, high keeps on decreasing. There will be a point where low will become greater than high, right? So as soon as low becomes greater than high, it means that we have checked all the elements, and so there are no other elements which need to be checked. That is, this is the condition when we have 0 elements, right? So this will return the blank. So this will become my base case. Over here, my base case will be if low is greater than high, I'll return. Now let us try to run this. And it was accepted, so I'm going to submit it. Over here we got the correct answer. So we discussed quicksort today. I explained to you the algorithm and how partitioning helps in it. So I hope you were able to understand. Thank you for watching. Please like, share and subscribe to the channel.